our group will continue build what was being sent by the previous group, basically. With this change from the traditional pharma model to the digital model, we see that there are a lot of increased the complexities, the breadth of the portfolio, and the risk that we have by moving into this model. So our presentation will focus a little bit deeply into the patent area. What implications does this change have in the patent area? And also specifically on the FTO process.
Thank you, Ivan. Yeah, now we are gonna compare how traditional pharma and digital pharma are structured, and then which kind of limits or boundaries both structures have. Like, having a look to the traditional pharma, we see a very clear, very simple structure, which consists basically in developing technology, which will be applied to a product, and at the end will be also the subject of the patent. And then this is going to be introduced in the market, and it's a very straightforward structure. It's very clear, very simple, and consequently, all limits or boundaries are very clear defined, are very previsible somehow, and it's very, very clear. Then when we have a look to the digital pharma, everything gets a little bit more complicated. We know that a whole digital ecosystem is created in which we have interactions between the core system and the management system. Data is now incorporated in this. So we have both systems that interact. We have the management, the interface that will be the app in this case, where all the information will be gathered. The patient will have its own platform structure with their profile, the drugs, meals, activity, all these data that they can use. Then we have the physician platform, where many other information will be gathered as well, and the insurance platform with relevant information for that. We see that this interaction creates more complex structure. We have many more information, many things to look into. So all limits, all boundaries, everything gets more complicated. So it's less, let's say, predefined. So we see here a very more complex structure, which all the difficulties that it carries. Now I will lead to my colleague, who will explain the assignment of the patent types.
The previous slide, yeah. Thank you. So here we assigned patent types to the respective technology areas. So patent types describe a class of established problem solution combinations in the patent literature that relate to an aspect of a business model realization, which is worth of IP protection. We would like to highlight, though, that patents are not the only IP class that are relevant to an overall IP strategy, especially in the digital space. Other classes like copyright and trade secrets play an important role too. So when we look at traditional pharma, which is an empirical and discrete technology, we can assign patent type 2, and this concerns a formulation of super fast acting insulin. But when we look at all the processes needed to deliver on the digital solution, which is a cumulative and complex technology, then the picture already gets more complicated. So parts of the processes may be patent protected. So we assigned patent type 1, 3, and 4 to the digital pharma ecosystem, which concern a closed loop control system for an insulin pump, optimized implantable glucose sensor, and also a data management system. And the anticipated protection of individual components of the system adds to the complexity of the IP strategy, and in course, obviously also on the FTO strategy. And I'll hand over to Russell now, who will talk you more through the FTO aspect here.
Thank you, Astrid. So as mentioned by Ricardo, in the traditional pharma model, we are considering a discrete technology, the molecule, and this is directly linked to the product, the future exploitable product, the drug to be sold. We can therefore define the technology by distinct international patent classification classes when considering the patents that we need to consider for FTO, and also look at specialized databases related to the structure of the molecule. Additionally, it's likely that we will have high competitor knowledge of those in the field, and thus we can consider specific competitors, and there'll be a relatively limited number of patent applications, patents that we'll have to consider. In contrast, the digital pharma model, as outlined by Astrid, we have to consider a cumulative and complex technology. So this includes a subcomponent of a sensor within the overall technology. This has got distinct international patent classification codes, particular applicants that will be associated with such technology, in this case, mostly in the medtech field. Turning then onto the patent type 1, again, this is a system related to the product. It will have different international patent classification codes for searches, and whilst overlapping, a differentiated competitor landscape and patent applicants that we'll have to consider. And then lastly, in relation to the data management system, we see here, again, different patent classification codes that we will have to search, a wholly different applicant for those patent applications, really focused on high-tech industry within that field. And it can be seen from the bottom portion of that slide there that the scale of the number of patent documents that we'll have to consider in any FTO is markedly different from the traditional pharma. So it can be appreciated overall then that the digital pharma freedom to operate has to consider a far larger patent landscape. There's a more heterogeneous competition, and this will lead to increased search cost and analysis costs, and the associated difficulties then and risks that will be associated with that FTO. So I'll pass on then to Erica to discuss this in a bit more detail.
Okay, thank you, Russell. So I'll be looking at the FTO process in Protection Center. And as was previously stated, this organizational structure tends to use the fortress monopoly IP strategy. And therefore, the FTO process has to align with that strategy. The objectives of the process would be to establish the scope of the search to be done and the depth of the search to be done, and to ensure it's undertaken in an effective manner. So first, we would start by breaking down the research item to establish the relevant attributes and elements that we would want to undertake the search for. Then we would need to be clear as to the regional scope of the search to be done, which would be based on our protection strategy. We would look to examining specific special databases. The example is given of a structural database. Of course, we could also consider information from clinical trials from competitors to get an idea as to their activities. Then the next step would be to specify the application-oriented classification symbols. And from there, we would define the relevant keywords. These steps would then allow us to create search strings and to then undertake the actual search. Finally, we would have to evaluate and analyze the search results. So that would be the process used for traditional pharma, utilizing a protection-oriented strategy and a fortress monopoly. Next, thank you.
Yes, thank you, Erica. So now we'll do the same exercise, but from a digital format. So we can see the FTO process is much more complex and probably will be more costly and will take much more time and effort. Maybe must involve also different competencies in the company to analyze the results of the search. We have additional steps compared to the traditional pharma FTO process in dark blue. So as an introduction, as we are in differentiation center here, we are more focused on USPs and customer benefits, and the benefits must be addressed not only to one customer, but to the end user, patient, the practitioner, the physicists, doctors, artificial pancreas suppliers, maybe also, and the insurances. So the benefits must address all the ecosystem. It's more complex. And the threat for the FTO can come from different areas and other applications other than pharma. Electronic and or mechanical technologies, but also digital technologies and digital platforms. So yes, it's more complex. If we go into each block, so we have this additional process steps. We have to weight attributes and elements and select the critical ones, because we don't have only one list of attributes. We have some different kind of attributes, and we need to combine them and to see how they interact. So we must select the best, the highly ranked system component. Then regarding the specific databases, we don't have specific databases for this. It's too complex also. So we remove these steps. Then we must specify application-oriented IPC, but we have an additional steps compared to traditional pharma. We must also specify the function-oriented classification symbol. For example, for traditional pharma application, it's the molecule. We apply this molecule. It's one technology to apply. It's quite simple. Here, the function-oriented is more related to how the technology interacts. How, for example, for the digital, the data management, how the system interacts with its environment. So it's more related to the function. So a lot of more IPC to consider. Then we define keywords, we create search string also. We have the search and evaluate the results like in traditional pharma. But we have final steps. It's to see if this result match the characteristic structure. It's not, okay, we have the FTO, yes, no. It's not that simple. And the match often is not clear because of technical complexity. So we see it's more difficult and complex. Now I let Alexander explain us the timeline approach for the FTO process.
Yeah, thank you. As we have already heard, switching from a traditional pharma business model to a more digital pharma business model changes the FTO process as such in terms of the steps that are to be taken, but it also changes the timeline of the FTO process. In traditional pharma, we have more like a static FTO at the end of the product, service, or business model development. Then we check if the fully developed product, so to say, our discrete technology has freedom to operate before the market launch. So we can say that the FTO analysis is rather performed as a snapshot. The FTO is checked. As we have already heard before, in digital pharma models, we have wider fields. We typically apply a differentiation center as the structure of our IP department. And therefore, we also have not only an empirical and discrete product that we want to exclusify and that we want to protect, but we also have the USP and customer benefits that we want to protect. So the FTO is done differently because the digital business models are actually continuously developed, expanded, modified, and many more departments are involved also, such as the product management, R&D, and IP, and also marketing is involved in this because customer feedback is very important if you want to develop your customer benefits. So the FTO analysis is, so to say, performed as a continuous support process all along the way from the product development, market launch, and the ongoing development, because we also want to continue on exclusify maybe new developments or new notions of the things that we have developed for our product. That means FTO is not only checked, but also, but more like FTO is more established on the way, on the route of our product development, and the continuous improvement and the continuous exclusification of our customer benefits. Thank you.